Hey everybody! What a wonderful conference! Like, have you ever been to a conference where you can play like ping pong and do bike rides and learn cool stuff and attend wonderful presentations? It's the first time for me, so I'm super excited. Yesterday we heard wonderful presentations about how to train deep learning models and machine learning models. Today I want to talk about how we can get them out to the people to use them. Hi, my name is Hannes. I'm a machine learning engineer at Caravelle, and I'm really excited about machine learning, but also machine learning infrastructure and how to get these wonderful models out. I had the wonderful opportunity to co-author 2 books. One of them is still in progress. But if you want to talk about NLP or machine learning infrastructure, talk to me after the conference or after the talk. Isn't it a wonderful time to be involved in machine learning projects these days? There's so many cool projects. Through machine learning and through machine translation, we almost have unlimited access to information. We can translate any text from any language into any other language. Through technologies like CNNs, we can now identify species much faster and more efficient than we were able to do a couple years ago. Through technologies like recurrent neural networks, we can figure out congestions, we can direct traffic more efficiently than what we were able to do a couple years ago. And then something which is very close to my heart, we can now use our energy sources way more efficient through machine learning and make use of that. But all these examples I just showed you have one thing in common. Can you think of anything? Or there's always a model lifecycle behind the scenes. And what do I mean with that is this. So every machine learning model starts with some data. We do some data versioning, we do some data validation. Often we have to do some pre-processing to take the real world data to map this to something what our model can understand. We train the machine learning model. Once we're settled on the architecture, we do often some tuning. We analyze the models, do some validation, usually around like, is the model performing better than what we have seen before? And then once we know that the model is better than what we put out in the world before, we talk about the deployment. Once it's out, we measure the performance of the model and how happy the users are. And then from that, we bootstrap new training data and the whole process kicks off. So this is basically an eternal life cycle. If you do this as a data scientist for the first iteration, it's always fun. If you do this the second time, the third time, the 10th time, the 100th time, well, that gets really boring. Well, that's why we want to automate this. And that's where machine learning operations come in, is basically automating this whole part. So since this is a lot to talk about today, I want to focus on how we can deploy these machine learning models. Some of you might ask now, why should I even worry about this? I'm a data scientist. Why do I need to worry about deployments? We have DevOps people in our company. Well, the deployment of your model is the only step which is between you, your model, and the outside world. And so you have basically the responsibility as a data scientist to get this model out. The DevOps folks are super helpful in terms of scaling, but you're the only one who can understand that model and knows how to infer correctly, what data goes in, what outputs are expected. Your DevOps colleagues might not be able to answer these questions. So basically, you're responsible for setting up the serving infrastructure. And the serving infrastructure is what allows the people around us to use the model. So basically, your hard work of like cleaning all the data, training that model, becomes useful in that moment when you deploy that machine learning model. So now the question comes up, how can you deploy machine learning models? There's a couple of options here. And in order to figure out which option is right for you, I thought of 4 questions you should consider to figure out like which way you want to go. The first question is, do you want to deploy your machine learning models in a central environment, meaning that you have one server and all the clients send their data to the server and basically get the inference back from a single node or multiple nodes in that server network? Do you need a GPU to infer your models? That could be the case if you want to do a lot of batch processes, you want to do the computation very efficiently, or your inference takes a lot of time, or maybe you have a computer vision problem where you want to parallelize a lot of the computations through a GPU. Another question you can think of is privacy a concern? Like sometimes you don't want to send the data to the server to infer, because in that moment you basically expose the privacy data to a third party. And then in some situations you want to distribute the predictions to the clients. So there's a couple of options here, and we go through them step by step. But the first solution I want to explain to you is how you can set up a model server. So how can we do that? A model server is extremely useful if you, for example, want to compute a large training set or a large data set. You want to do batch inferences, or you want to do online inferences. It's a wonderful setup if you want to do A/B testing. So if you have a model and you want to roll out a second model and you want to figure out which one works better, in that moment you want to basically swap them out depending on the inference. This is something you can easily do with a model server. And then if you want to optimize your model for a specific hardware, the best chance you can do this is through a model server, because in that moment you control the hardware. So if you want to optimize it for a certain CPU instruction set or a GPU, I would go with a model server. Let's talk about a couple of architectures. And the simplest architecture you can come up with is basically a model server which loads that model and takes API requests. It takes the request, it infers the model, takes the prediction, and responds to the HTTP request. It's a fully sufficient architecture for a simple deployment. Once you want to distribute or sort of like share this model setup across different hardware types, maybe in different cloud providers, maybe you want to share this with your colleagues who run on a Windows machine, on a Linux machine, or maybe a Mac, then you want to keep the dependencies encapsulated. And you can do this through Docker. You can basically wrap everything into a container and you ship that image to your cloud provider or to your colleagues. And whatever runs in that Docker container always runs in the same setup. That's a really nice setup if you want to reproduce your deployment setup. If you want to scale this, and this is where probably a DevOps friends come in, you can use something it's called Kubernetes. And in that moment, you manage the orchestration of the different containers. You scale them up and down depending on the traffic, depending on workloads. And you basically, if you have one instance which is running in this container, it gets replicated. And all of a sudden, you have more replicas of that container to answer prediction requests. And that is a highly scalable option. And it's also very useful if you want to do A/B testing or if you want to serve multiple model versions. So let's talk about a couple of options. How does it work in reality? And so the easiest option is using Flask. And Flask is a very commonly known Python API framework. It works with all machine learning frameworks in Python. And it's a good, quick and dirty deployment option. And I'm saying quick and dirty because all of a sudden, you will see in a second, very quickly the API code will be intertwined with the model code. Your APIs are not really consistent. You can change the payloads whenever you want. You can change the path of the URLs at any point in time. And it's also a very inefficient use of your computation resources. So for example, if you have an HTTP request, it does the full round trip through the prediction. It gets the HTTP response. But if you send single requests, then basically it would lock up the GPU in that moment, for example. So if you would want to implement this quickly, here's a really quick and dirty implementation. You load all the required models, all the required packages, Flask, you use Keras in this moment. I throw in a custom pre-processing function here, which we have to develop ourselves. But basically, the next step is we load our model. Here in this moment, we use an HDF5 file. We instantiate our Flask app. We come up with we define a route, and then register it as a post request, get some form data, And then basically we do some pre-processing, infer the model, and whatever comes back is being responded to that HTTP request. I would highly recommend not to implement it that way. It's really the simplest version you can implement it. There's absolutely no error handling, no timeout handling, etc. But it's basically how you would infer your model in a quick and dirty setup. I highly caution you using that, because very quickly your setup will look like this. It gets really messy, and you lose control over like which version am I using here, and like you want to use different versions, and then the payloads change, and everything gets really out of hand. One option to get around this is switching to TensorFlow serving. A couple good sides about TensorFlow serving is it separates the API code from the model code, and I'm going to show you this in a second. It's a really easy deployment, and you can infer your model through a batching process. So if you get a bunch of requests in a certain amount of time, it will package them up and request them in one shot. So it's a really efficient use of your hardware. It provides you a couple communication endpoints out of the box. It's gRPC and REST. And the wonderful thing is, if you have multiple model versions, you can host them together. You can switch back and forth between different models and different versions. That's a wonderful setup. A couple of downsides. At this point in time, it only works with Keras and TensorFlow. There's some talk that it's supposed to work with XGBoost in the future. You have to use Docker, or you have to run it on a Ubuntu Linux distribution. And then the last downside is like they have very cryptic error messages. So that's a big downside. It's very easy to set up. If you have Docker installed, you can basically run it with this command. In this case, we open one port, which is the port for the REST API. We load one model, and we bind our folder on the host machine to the Docker container. And then once you run this command, you're going to see a bunch of outputs. And the last line is the interesting one, where it says, hey, the REST API is loaded, the model is ready, you can now infer. So now if you want to infer that model, in this case, it's a little text example. You basically specify the URL, you submit your payload, and then you get the results back. And the results would basically look like this. So it's like you see your different classes, and you see the likelihood of that class, or the score for each class. So in the code earlier, there was absolutely no model loading, nothing. You nicely separate the API code from the model code. So over time, when you have multiple versions and multiple models, everything looks very clean and well sorted. If you want to learn more about TF serving, we have a publication coming up. The co-authors are in the audience, and if you have a couple questions, we're happy to answer them. We have a setup instructions, and the TensorFlow documentation is also wonderful. And of course, we share the presentation. Yeah. A couple of other options for your model server. So if you say, hey, I have a scikit-learn model, what can I do? I have a PyTorch model. It doesn't work with TensorFlow serving. Here are a couple of other options. There's a company in London called Zeldin. They have their own deployment setup, and that works really nicely together with Kubeflow. There's a talk later on today about Kubeflow. It's a good setup for scikit-learn models. If you train PyTorch models, GraphPipe by Oracle is a good setup. They can load Onyx model definitions, and then they give you, therefore, access to Caffe2 or PyTorch models. And then I think after this talk, there's an introduction to ML4ALL from Databricks. That's also a way to deploy machine learning models. And then there's a wonderful package called Simple TensorFlow Serving, which also allows you to use scikit-learn and other deep learning models. Of course, there are cloud providers. I just want to mention them for completeness. If you want to quickly deploy your models, there is Google, there's Amazon, and there's Microsoft. They all work very similar. It quickly gets really pricey, because you have to pay for every version of the model, not just for every model itself. So it's probably a good way to get started, but as soon as you run multiple versions in the same instance, then it gets pretty pricey. All right. I mentioned earlier there are other options to deploy machine learning models, and the other option is you can deploy it to the browser of the user. So these days, if you if you're in the Keras and TensorFlow world, then you have the great opportunity to deploy to the browser through TensorFlow.js. And here's a wonderful example of PostNet. So it basically does all the inferences in the browser. It figures out the positions and then has like a wonderful model where it looks up similar images online, which match that position. So it's a nifty project. It's a wonderful setup if you want to honor the privacy of the data. So in this moment, if you have a situation where you want to figure out if the data supposed to be submitted to a server contains sensitive information, you can run the classification in the browser itself, and you can stop the user from uploading it in that moment. It doesn't require any model server because you basically ship the model to the client or to the user. Again, you're limited to TensorFlow and Keras at this point in time. You have to convert the model. I will show you this in a second. And then you're limited by the model size. You can't really ship like large embeddings because everybody has to download that model, and you can't really stream like 100 megabytes before a simple classification can work. And also, it's something you have to consider. You basically ship your intellectual property in that moment. So if you work for a company and you don't want to share your model, that solution might not work for you in that case. Oops. So how can you use TensorFlow.js? It's a normal process. So you would basically train your machine learning model on your machine, as usual. You export your Keras or your TensorFlow model. And then you install this TensorFlow.js package in Python, which allows you to convert your Keras model or your TensorFlow model to something which you can then integrate in your JavaScript stack. And then in JavaScript, you can basically infer. Similar to Keras, you can do model load and then model predict. So it's a wonderful setup these days. Another option I want to highlight is you can now deploy machine learning models to edge devices. And edge devices would be mobile phones, watches, Raspberry Pis, little hardware devices without internet connection. That's a wonderful setup if you don't have internet access. And the way you can do this is through TensorFlow Lite. Here's a little example where you run this inference model straight on the mobile phone. It could be a Raspberry Pi as well. It could be Arduinos, like tiny hardware. And the wonderful thing about the library is it allows you to reduce the complexity of the machine learning models. So what they do behind the scenes is they quantize the models, and they do a lot of pruning to reduce the memory footprint and the CPU requirements of that. And that allows you to run machine learning models on very limited hardware, and you honor the battery life. So potentially on the phone, you could easily run that. The CPUs are strong enough, but you don't want to drain the battery for your inferences. Again, the downside is at this point in time, it only runs with TensorFlow and Keras, and you have to convert your models. The biggest downside in this case is only certain TensorFlow operations are supported at this point in time, but the number of operations are growing by the day. So you will see more and more machine learning models going out to edge devices, and there's a big push inside of Google to extend the number of ops. The conversion process is very similar to what I showed you earlier with TensorFlow.js. You export your model, you use a converter, which is already coming in this case with TensorFlow, and that does the quantization of the model, and you can also do some pruning. And once you have this model, sort of like you shrink the model to something you can package onto your edge device, and then you can integrate this into your Android or iOS app. I want to do a quick recap. So if you want to decide which platform to use, I would start with is privacy a requirement for you? If it is, think about, do you have a network access or not? I would heavily go with TensorFlow Lite or TensorFlow.js options. If you're not concerned about privacy, then think about, do you want to scale that model? Does it have to run in production environment? Do you expect a lot of people to use it? If you just want something quick and dirty, again, you're more than happy to use Flask, but it's something which becomes which grows into a legacy project. I would highly recommend to use something else than Flask, and TensorFlow serving is a really good option. A quick summary of what to use with the different platforms and frameworks. Scikit-learn runs on various platforms. PyTorch is supported by a couple devices, and platforms. Okay, demo time. Now let's pray for the demo gods that everything goes well. Let me switch here. Can you guys see that? Oh, wow, I could not make this smaller. Let me see if I can. All right. So the last command down there is basically the Docker command I showed you a couple minutes ago. It will fire up our Docker container, it will run it, and then open up the two ports, 8500 and 8501. 8500 is the standard gRPC endpoint, and 8501 is the standard REST API endpoint. We bind my local folder in my temp directory where I saved all these models so far, and we bind it to this internal folder model/movie. And while this is starting up, what I did prior to this talk, I was training a machine learning model which basically takes a movie description and tries to figure out, like, is it an action movie or is it like a thriller or a comedy or whatever. And let me show you. I have, this is also very small, but I basically have a model here, which is a model I only trained with like 10 steps. So basically all the weights are still random. So we would expect complete garbage coming out of this model. And I will prove that this is complete garbage which is coming out. So here we have two endpoints. We have the gRPC endpoint and we have the REST endpoint. We got the message that the model was successfully loaded and we're ready for inferences. So let me switch back. And we have our movie description here. I think that's a James Bond movie. And I would expect something action, thriller related or something like this. We have a little inference code, very similar to the code I showed you earlier in the presentation. And then we infer that. And then basically the weights, or sorry, not the weights, the labels, the certainty on the labels is more or less the same. So basically the network has learned nothing. It's completely useless. So now prior to the talk, I prepared a model and I trained it with way more iterations. So we can basically take that model now, drop that into the same folder, and behind the scenes, the model manager of TensorFlow Serving discovers that there's a new model available, automatically unloads the old one, loads the new one, and swaps it out. I haven't done anything. I didn't do anything besides dropping in that new model. It takes a little bit of time. The loading is a little bit of memory intensive because we're loading an entire universal encoding model behind the scenes. I think we're ready now. Let's execute the exact same code. So we have our James Bond movie. That function is already loaded. So let's do the inference here. Hey, it's also nice and fast. And all of a sudden, it comes back with this is the top label, and then this is I think the first one is action, and the last one is like a thriller or something. So it works. Okay. So yeah. Let me switch back. Okay. With that, I wish you happy deployments. I hope this was a useful introduction of how easy it is to deploy deep learning models. And thank you.